Alright, this video is about what's called one-sided limits. Okay, so what you need to understand is that there's what's called a left-handed limit, which is the intended height of a function as x approaches from the left, so you're looking at it from the left. And then there's a right-handed limit. It's the intended height of the function, or the y value, as x approaches c, whatever the limit is. So the limit as x approaches c, as it approaches this number from the right. Okay, it'll make more sense as you see a graph, but know that there's a left and right-hand limit. And a limit for the whole function only exists if the left-hand limit is equal to the right-handed limit. If they're unequal, then you say the limit does not exist, which you've seen before. Okay, and they'll notate it, the limit as x approaches c. If it's a negative, that's from the left. And then if it's from the right, x approaches c is whatever number from the right. Okay, that's the way it will be notated on your assignment. Alright, so let's look at this. I have an equation, and it's asking me for the limit as x approaches 0 from the left, from the right, and then overall. Remember, these two have to match in order for this last one to exist. Alright, so how are we going to approach this? Well, so we create an XY table of values using our favorite little points to plug in. Alright, so I put in a -2, I get -4, absolute value of -4 over -2. That's +4 over -2, which is -2. Put in a -1, I get -2 absolute value over -1, so it's a +2 over -1, which makes it -2. Now 0, well 0 is 0, but over 0, that's undefined. Okay, so there's a hole. This is undefined. Okay. If I put in a 1, I get 2 over 1, which is 2. Put in a 4, I get... So if I plot these points, -2, -2, -1, -2, and then there's a hole for 0. Okay, so it doesn't really... It comes all the way up to it, but then it doesn't exist here, so it comes this way. Okay? Then it jumps up to where x is 1, y is 2. Where x is 2, it's 2. So what's happening is it's getting me this graph, okay? It's disconnected, discontinuous, and there's a hole where x is 0. So if I look at this, the limit as x approaches 0 from the left, so I'm looking from the left, that looks like it's approaching -2. What's the y value there? It's -2, okay? The limit as x approaches 0 from the right is +2. Okay? Do these match? No, they do not match. So I would say it does not exist. Okay? I hope that makes some sense. Let's try another one. Okay, we're looking at 1 from the left, from the right, and overall. We've got two equations here to plug in. So let's just do 4 minus x really quick. These are values. We need to go around 1, so let's do -1, 0, 1, and 2. Plug that in. -1 gives me a 5. So give me 4. 4 minus 1 is 3, and 2. So, what I have so far is x -1, y is 5. 5, 4, 3, 2. So we have this line going this direction, okay? Then the other line is 4x minus x squared. Use the same x values, guys. Put in a -1, I get -4 minus -1 squared is +1. So this will give me a -5. Put in a 0, well that's just 0. Put in a 1, I get 4 minus 1, which is 3. Put in a 2, I get 8 minus 4, which is 4. So at -1, I'm at -5. Way down here. 0, 0, 1, 2, 3, and at 2, I'm at 4. Alright? And it's a parabola, so it's going to peak and curve back down. So if I went to 3, All right, so that gives you the general idea. Now we look at the limits. As x approaches 1, what's it doing? Well, here's where x is 1. What's the height right there? Well, it's about a 3. Okay. As x approaches 1 from the right, going this direction, it's still coming to about a 3. All right, from both graphs. All right, and so the overall limit as x approaches 1, since these two match, my overall limit is a 3. Okay. All right, last example here. The limit as x approaches 1 of 2x plus 3. Well, graph it. Easy one to graph. Okay, nice little linear function. As x approaches 1 from the right, so I'm looking this way, getting closer and closer to x is 1. What is that y value? Where x is 1. Well, that y value is 5. So my limit is 5 on that one. Okay. Okay, so a word problem. To ship a package, a delivery service charges $8 for the first pound, $2 for each additional pound or portion of a pound. Let x represent the weight of the package, and let f of x represent the shipping cost. Show that the limit of f of x as x approaches 2 does not exist. All right, so this looks a little complicated, but it's really not. Don't let it freak you out. Think of this as your xy axis right here. And we're just going to be messing with quadrant 1. Okay, so this is x is 0. I can draw a straight line. 1, 2, 3. Y goes all the way up to 12. 1, 4, 8, 9, 10, 11, 12. So here's 12. Okay? So we have our landmarks basically. So from where, look at your inequalities. These are open circles and these are closed circles, right? So keep that in mind as we go along. From 0 to 1, it's $8. From 0 to 1 pound, it is $8. Okay? So I close circle here and I connect them. From 1 to $2, from 1 to 2 pounds is $10. So anything over 1, I should say. Anything over 1 all the way to 2 is 10 pounds. Anything above 2 pounds, so not exactly 2, but a little bit higher, all the way to 3 pounds is $12, and so on and so forth. Okay, it would keep on going like this, but it makes a stair-step kind of graph, right? Open circles, closed circles. So what I'm looking for as the function as it approaches, as the limit as x approaches 2 from the left, the limit as x approaches 2 from the right. If these two don't match, then there is no limit. It does not exist. So let's do this from the left. Okay, as I approach from the left, looking this way at my graph, as I get closer and closer to 2, it looks as if my limit should be at 10, right? Okay, 10. Looks like it's 10. Now, from the right, come this direction. If I'm looking at it this direction, what is the y value as x gets closer and closer to 2? Well, it's up here at 12. Okay? Because the left-hand limit is not equal to the right-hand limit, the limit does not exist. And that's what I've done to prove it. The left limit is 10, the right limit is 12. Therefore, they do not exist. All right? You're not going to have anything that complex, but I just kind of wanted you to see what it looks like in a real-life example. For class, I want you to try this one. Okay? Evaluate the left and right-hand limits. Determine if a limit exists. Okay, don't freak out because there's three different equations. Graph each equation. Okay, you're going to use these inequalities to help you limit it down. And if you still are confused, we'll work it out in class. Okay, good luck. See you tomorrow.